factorization, which is the algebraic method and involves factoring polynomials that are a difference of squares. So as the name suggests, I will just show you how you are going to identify that this method is going to work. You will have here the difference or the subtraction operation between the factors or between the polynomial. So subtraction is the mathematical operation that is going to be there that brings you the name difference. And then you have two terms with squares. So here you can identify the power is 2. So you have two terms with squares. So that brings the name difference of squares. So you will use this difference of square identity. This is an algebraic identity whenever you need to factor a binomial. So definitely it will have two terms, as you can see, the first and the second, and with a subtraction in between. So what is the identity? Let's recall, this is the difference of square identities. It can be written as the product of the two factors a plus b and a minus b. So just remember, they are going to be of opposite sign, and we are going to multiply them to factor using difference of squares. So you're basically going to factor two binomials, and what you will get is the product of two terms. So let's use this. Let's take an example. So if you have x square minus 16. Now, right now this is not in difference of square form, but we have this number 16, which we know is a perfect square. So it can be written as square of 4. So now it is in the difference of square form. There is a difference sign, there's a subtraction, and there are two terms, two binomials with the squares. So we can definitely apply the identity. And if you want to compare a square minus b square with x square minus 4 square, you know a is going to be x and b is going to be 4. So that's how you get a plus b and a minus b. So very easy identity and very useful for factorization. Let's take another example. This is a little different form. When you look at this question, it's not so easy to identify that you are going to use the difference of squares. So let's write the identity here. A square minus b square is a plus b multiplied with a minus b. So what is the first term here? This is the first term. So you have a square with x, but you don't have a square with 1 over 49. So let's express it in a perfect square form. Also, the second term here is 81, which is not again in a difference of square form. So we are going to write it as a perfect square. So this becomes 1 over 7x to the power 2 minus 9 square. And this is coming directly from the squares that 81 is a perfect square of 9 and 49 is a perfect square of 7. So now it is in difference of square forms. There are squares of two terms. This is the first term a, the second term b, and there is a subtraction in between. So you can write a plus b and a minus b. You can apply the identity. So what is the first term? Let's write. The first term is x over 7 and the second term is 9. Both are perfect squares. So very easy to apply this identity, and here we have got the two factors. Now I want you to try on your own some questions which I'm going to be giving you here, and then we are going to discuss it. Take a minute to think of them and then you can check your solution. So for the first one, let's see. Is it a binomial? Yes, it is. Is it a perfect square? Yes, but you need to put it in a perfect square form. So you'll write 121 as 11 square and then your a plus b and a minus b. The difference of square identity gives you the answer. Okay, let's come to the next one. Here you have 9y square minus 169x square. But again, this number 9 and 169 are not with the proper square notation. So we are going to convert them first. 9 is the perfect square of 3. 169 is the perfect square of 13. So you can first write it in that manner. So maybe we want to add one more step. This is 3y square minus 13x square. Now your a and b are very clear. So a plus b and a minus b. That's the factor form using difference of square. Now one more point I'd like to raise here that you need to be careful of. Either way you can write, it won't change your answer. If you write the positive sign first and then the negative sign and the terms in this order, it is also correct. Or if you write the negative sign first and positive sign later, it will not make any difference to the solution. Okay, now let's come to this. Is it in a difference of square form? You need to be careful of this one. It's a tricky one. The power here is 4. It's not square. Again, 16 is just a number not written in a square form. So we need to first convert it into difference of square. So in order to write, I will write x square and then raise it to the power. Also, can you tell me which number should be coming here, which is a perfect square? Definitely 4. So now you can break it up. So it gives you x square minus 4 and x square plus 4. Now think and tell me, can we apply the difference of square identity one more time? Yes, because 4 is also a perfect square. So it further boils down to x plus 2, x minus 2 and x square plus 4. So one step was added more, and for the third question, it's an important one. Your difference of square identity was applied 2 times in the same question to factor.